Yeah, good morning, students.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Yeah, good morning. So first hour, actually, you had software engineering class, I suppose, but sir will be taking at 9:30, that is second hour. Okay, so we'll be having DBMS now and then followed by sir's class. You're all able to see my screen?
Yes, ma'am.
Yes. So let us continue with what we had done in the last class. So last couple of classes, we have been talking about concurrency control. Can anyone tell me the techniques that we have learned under concurrency control? What are the techniques that come under concurrency control? Can anyone let me know? Anyone? Benaka?
A minute, ma'am. I'm referring to my notes. Just
Mohit, why you have not attended last class?
Ma'am, there was placements. I was preparing for it, ma'am.
How did you do?
I did it well, ma'am.
Okay. Anyone else?
Yes, ma'am. In concurrency control techniques, like ma'am, resolving read-write conflicts and database consistency, preserving database consistency.
Concurrency control techniques, when we say, how are we trying to, what you are trying to tell, Raman, is all kind of operations that we do on that. Read write operation, we are checking whether there is a write lock or whether there is a read lock. All these things are all operations that are performed as part of concurrency control. But when you talk of, when we ask you what are the different techniques of implementing concurrency control, right? We learned the first one was using locks. The second,
Ma'am, two-phase locking protocol.
correct. That is one of the algorithm, but it comes under the technique of locks. So when we say locks, under locks we have binary locks, we have multi-mode locks. Then we have an algorithm that is the two-phase locking algorithm. All that is fine. But when we talk of concurrency control in general, this is a major topic. How do we implement it? One is locks, the other one is using. We said we do it using timestamp.
timestamp.
Yeah. Under each of these, we have, of course, different variations of implementing it, and we have also seen a couple of algorithms under locks as well as under timestamp. We saw under lock we had the 2PL algorithm. Again, under 2PL, we saw several variation, basic 2PL. We saw strict 2PL, rigorous 2PL, and all that stuff. Again, under timestamp, we saw the basic timestamp ordering. Then we saw strict timestamp ordering, and then we saw a Thomas Wright rule. These are all again different, algorithms that come under timestamps. Then we also saw one more technique, what was using the multi-version technique or multi-version technique for concurrency control. This also we saw, wherein we saw some compatibility table for logs, and we made use of the concept of certificates and all that stuff. So that is your multi-version. So this is what we learned under concurrency control technique, which is very important and from the point of understanding the DBMS concepts. Then yesterday's class, we went into recovery techniques. So here again, I had put down what are all we are going to learn under this. And of course, we started with some recovery outline and different algorithms. That is where we started in the last class. What is basically recovery? Why do we need recovery and how it can be done? What are the different ways in which you can do this recovery? And we also saw some algorithms like undo, redo algorithm, undo, no redo, or redo, no undo. So these kind of algorithms we have seen in the last class. Right, I think that is where we stopped in the last class. Let us continue with, I also talked about disk caching, wherein I think we stopped at some of these OS concepts where we were dealing with, where we make use of some of the page replacement algorithms. We could be using a FIFO algorithm, we could be using a LRU or least recently used optimal replacement algorithm. I think a couple of them you have learned it in OS. I don't have to go into the details of what are these page replacement algorithms. And why do we make use of it? Whenever you are trying to put it in the cache memory, right? All the updations will be done here, and then later on you are making the final updation in the disk, right? So that is how we are trying to that is how we try to shuttle between this cache memory and the disk space for execution of any program. And whenever your cache memory becomes full, you will have to flush out some of the pages. If you are making use of the paging concept, you will have to flush out this page into your disk and bring in the new page for which you want to make some changes. This concept you also call it as swapping, or we also call it as roll in and roll out. Have you all come across these terms in OS? Can anyone confirm that?
Yes, ma'am.
Yeah. You have learned about roll in, roll out, you learned about swapping. So your cache memory is always small in size. So the cache memory will always become full when you bring in the pages from the disk to the memory. All right. So when your memory becomes full with some pages, when you want to bring in a new page, so you will have to transfer a new page and swap out a page from cache and then bring in the new page from the disk. Right. I think there is one term for that. No, can anybody recall that OS concept? Page fault. Yeah. So there will be a page fault indication by the OS, which means that the corresponding page is not there in the memory. So that page has to be brought from the disk into the memory, and then you will have to continue with the execution. Right. And there is also, every time you need not write the whole page back into the disk, there is also something called as the dirty bit or the modify bit. So whenever we are updating OS updates a particular page, this particular bit will be set to 1. That means this particular page or that word or block in that page has been modified, and you try to update only this particular page into the disk. You are not going to do the whole thing always. Otherwise, if you have not made any changes to that particular page, you are setting that dirty bit to 0. Any doubts still here? I think these, as I told you already, recovery and your OS concepts are always intertwined. You cannot see both of them, separately. You have to. I mean, there is always a coordination. There is always a linking between the OS concepts and the DBMS concept when it comes to recovery and certain concepts like this. Any questions till here? Till here, I think this is where we exactly stopped in the last class. Just to give you a quick recap, that's all. I am yet to start with today's concept.
No doubt, ma'am.
Yeah. Right. Now, I told that we are having a dirty bit or today's, let us continue with from where we have stopped. Okay. So today we'll be looking a little more into what are the different ways in which you can, take a backup and how their pages are updated in the disk and so on. As I told you already, some of these concepts we would have already touched upon in operating system. And as we cannot see both of them as two separate entities, we cannot do that. So we'll have to actually overlap certain concepts of DBMS and OS when it comes to recovery techniques, right? Because OS as such plays a very major role in resource management. All of you know that resource management, efficient usage of all the resources of a system and all that stuff. Okay. Now, I told you that if this memory, let us say this is our main memory or a cache memory, whatever. Okay. This is the main memory that we have. Of course, this concept you would have studied in OS. I'm just taking cue from there. All right. So we have the disk, and let us say we are using this concept of paging. Our disk is all, we have stored all the pages in the disk. Each one is a page. Okay. Now, when you want to do some kind of some execution, there are several pages. Whenever a program is under execution, you call it as a process, right? And all those pages should be brought into the memory before the execution starts, right? Now, when the execution is going on, if a particular page is not, that is required for execution, is not there in the memory, then OS is going to result in a page fault. Page fault means the corresponding page is there in the disk, it is not in the memory, so that page has to be brought from the disk, it has to be loaded into the memory, and then you continue with the execution. Right? So that is what is done. If the main memory has no space to house that particular page, then what we do, we have to swap out one page from here, make room for the new page that has to be brought in. Then from the disk, you are bringing in the page that is currently required for execution, and then the execution continues. This is what you call it as a, which page has to be replaced. That is when you talk about our page replacement algorithms. Right. Now for this case, we also discussed about this dirty bit and modify bit. If the when the buffer contents are replaced, okay, from the cache memory, you have to write it back into the disk page. You write it back into the disk page only if the dirty bit is going to be set to 1. If it is not set to 1, then that means it need not be written back as of now. You have to maybe write it later. Now, whenever you are writing a buffer back to the disk, modified page or a modified, you call it as a modified buffer, you can call it as a modified page, you have to, whenever you have made updations, you have to write it back into the disk, because your disk should have the updated copy. There are two strategies that we can employ to do this concept. Which concept? To write back to the modified buffer back to the disk. You have modified a page, you have modified a particular buffer. So when it is modified while executing, it has been modified when it was in the memory. Now you will have to write it back to the disk and update the corresponding contents in the disk. To do this, there are two strategies that can be followed. Apart from your dirty bit, dirty bit or the modified bit, which is set. One of the strategy, concentrate, these are all important. It will help you in your placements also. One of the strategy is called as in-place updating. In-place updating means it will write the buffer back to the same original disk location. I said, what are the strategies for? These two strategies we are discussing here is for what? For what are the different methods or strategies to write back the modified buffer or the page back to the disk. What are the different ways in which you can update the corresponding disk? item in the content in the disk. Okay, one strategy is called as in place updating. So what do we mean by in place updating? We are going to it is going to write the buffer back to the same original disk location. If I have taken that particular page from this location, let us say from here, it will be written back to the same location. Are you getting me?
Yes, ma'am.
So what will happen to the old value which is there? Suppose there was some old value was already there, right? So you are going to overwrite the old value of any change in data item on the disk. So this, since you are writing back to the same location, the old value will be overwritten. Your old value will be lost. So in that case, only one copy of the disk block is maintained. You don't have any other copy of that particular disk block. That is what you call it as in place updating. You have taken that particular block. This is the block. Look here. Let's say I call it as A. This is the block that you are taken it to the memory. Okay. You have made some changes and now you have taken it here, that block A. Okay, and then you have to bring it back. You have to update now the disk. What you will do, you will bring it back into the same original disk location. If you are updating it at the same original disk location, you call it as in place updating. So in that case, what will happen to there is already a copy in the disk, is it not? You are just taking a copy of it. So whatever old value was there, that will get overwritten. So that is one of the strategy in order to one of the strategies to write back the modified buffer. The second strategy, we call it, first strategy is in place updating. Second strategy, you call it as, one second. The second strategy, you call it as shadowing. Okay, what here it happens? Here the updated buffer, whichever buffer is updated, it will be written in a different disk location or a new disk location. Different disk location or a new disk location you are trying to write it. That is why you call it as shadowing. So since you are writing it in a different location, multiple versions of that will be available, or rather multiple versions of I'll put it this way. Multiple versions of the data item are maintained in the disk. Okay. In the previous case, what's happening? You are writing it in the same original disk location. So the old value is lost, or old value is overwritten by the new value. Whereas in case of shadowing means what is happening? You are copying that particular updated value is copied to a different disk location. So what happens? You have the old item also, you have the new value also, both are stored or both are maintained in the disk. That is why we say multiple versions of the data item are maintained. Any doubts? Any clarifications? So multiple versions of the data item are maintained here. Now, the old value of the data item, that is before you update, there is some value already there that becomes old now because you are trying to update it. The old value, you call it as BFIM, which stands for before image. The old value which is there in the disk before updating, there is some value already, right? That has become old now because you already updated it. The value has already changed. So the old value before updation, you call it as BFIM or the before image. The new value after updating, you call it as AFIM, which stands for after image. So in shadowing concept, what's happening? Both BFIM and AFIM can be kept on the disk because you are storing everything under different location. Both AFIM and before image and after image can be kept on the disk. In fact, for shadowing, you need not maintain the log. For recovering, you need not maintain the log because you are anywhere keeping the old one also, new one also in the disk only. So there is no need to put again one copy in the log entry. It is not required actually for recovery. Any questions up to here?
No.
Ma'am, when we update to newer version, why do we need to store the older version?
No, that is one of the technique. That's all. That is one
Oh,
of the technique because you never know at when you. I will tell you when we go further. I will tell you because when
okay.
you need to roll back a transaction, you may
Then
have to roll back up to certain point, right? So in that case, you may need certain old values. You may not need the newer ones. You have to abort it. These things are there. Why do you maintain something in the log? Because whenever something you have to abort something or you want to roll back something, you want to redo something, you have to undo something, you need to keep a track of what all has happened, which value was there, which value got updated. These things you will have to keep track of. Now,
okay.
since you are keeping the multiple versions of the data in the disk itself,
Yes, ma'am.
you need not maintain a log. So these older values are required when you want to undo some operations or redo some operations. You need to keep track and trace back. That is the only point.
Okay, ma'am.
Yeah. Any other questions, anyone? So we saw, let me quickly summarize that. We saw two different techniques. One is two different techniques for what? For what to say, updating the modified data item or modified buffer back into the disk. So we have seen two strategies. One is in place updating and the other one is shadowing. In place updating means you are writing it back to the same original disk from wherever it was moved. You are writing it back to the same location. So the old value simply gets replaced with the new value, or rather the old value gets overwritten by the new value. The second case, what is it called? It is called shadowing. You are writing it to a different disk location, right? So the different disk location you are writing, that means you are maintaining the multiple versions of that particular data item. Before updation data is always called as BFIM. After updation data is always called as a new item is called as after image or AFIM. So in case of in-place updating, both BFIM gets overwritten by the AFIM. That is an important concept you have to understand here. In case of in-place updation, what happens? BFIM is replaced, or you can say it is overwritten by AFIM. What is BFIM? Before image, the old value. After updation, the new value is called as AFIM, after image. So in case of in-place updating strategy, BFIM is replaced or it is overwritten by AFIM. What happens in case of shadowing? Anyone? What happens in case of shadowing? In case of shadowing, BFIM and AFIM both are placed in different locations. You are maintaining both of them. Both of them are stored in different locations. They are not overwritten or something. Both the versions are maintained. So for shadowing, I said there is no actually not required, but it is always better to still maintain the log. Okay. So that's about in place updating and shadowing. Next, we will see what do we mean by write ahead logging. See, these are all some of the important terms that you will have to understand. Okay, so let's try to understand what do we mean by write ahead logging. To know this, all this you should know in place updating, shadowing, BFIM, AFIM, all these terms you should be knowing. Only then you will be able to understand what is all these things. Right. So in case of write ahead logging, okay, what do we mean by write ahead logging? Whenever we are using this in place updating, okay, we already know that we should be using a log for recovery. I said that when we are using shadowing, there is no need for log because you are anyway maintaining the multiple versions in the disk. But when you are using write ahead logging, when you are using in place updating, it is necessary to use the log because your old value is getting replaced or overwritten by the new value. So it is necessary to use a log. In this case, the recovery mechanism should ensure that your BFIM is getting recorded in the log entry. Right? You have to make an entry. What is BFIM? Whatever is your old value. You have to ensure that this old value is entered in the log, system log. And you are actually having this in the disk as well before this value gets updated by the AFIM value. That process we generally call it as write ahead logging. Write ahead logging. That means before you replace the BFIM with the AFIM value, you'll have to make a log entry of the BFIM. That is why you call it as write ahead logging. Is it clear to you all? I said that for whenever you are using a in place updating, the BFIM value should always be entered in the log, and the same value should always be also appearing in your disk before that BFIM value in the disk is replaced by the AFIM value. Actually, there are two types of log entry information for a write command. Whenever you want to do a write command, there are two types of log entry that you can make. What is the information that is needed for undo, and what is the information that is needed for a redo? For a redo type log entry, it will include the AFIM of the item. Okay, it includes the AFIM. That means in your system log, you are going to write the AFIM value also. Why? Because whenever you want to redo some operation, this AFIM value is required. That is why the new value of the operation is also set in the log. Okay, we talk about undo type. Now, undo type log entry will always include the BFIM, because if you want to undo the operation from the log, okay, in that case, then you require this particular information. So log entry, actually there are two different ways or types of information that you are putting in the log entry, or there are two types of what I can say, log entry information which is included for a write command. What is the information that is needed for a undo, and what is it that is needed for a redo operation? If you are trying to do a redo type entry, it will include the AFIM value. AFIM is what? After image. That is the new updated value should also be recorded in the log. That is because if you want to redo, because of the transaction is aborted, transaction is failed, something happens and you want to redo this operation, in that case, you will have to make use of the same. Undo type log entry will include the old value of the item, because you have to undo something which you have already done, right? So that is the thing. Now, a couple of more recovery terminology, let us see. We next see what is steal and no steal. What do we mean by steal and no steal? Any idea? These are all some of the important terminologies which comes under recovery techniques that you should know. What do we mean by in placing? What do we mean by shadowing, right ahead logging, steal, no steal? These are all things. Redo algorithm, undo algorithm, what are log entries? These are all very important concepts when we talk about recovery techniques. Okay, now we have these terms called steal, no steal. We have one more term called force and no force. Okay, these terms we are using which specify when a particular page from, I'm writing it so that you can understand it better. When a page from the database can be written to the disk. From the cache. That means I said we are transferring from the cache to the disk. Is it not? Whatever page we have modified, we have to transfer it to the disk. Okay, when can it be done? When can we do it? That is what is described in these two techniques, steal, no steal, and force, no force. Now, if a particular page which is updated by a transaction, let us say. So you have made some transactions on the pages and that page has been updated. Some changes you have made to that particular page. Suppose you cannot write it before the transaction commits. That means this particular page you cannot write, it has already been updated. This page is already updated because of this particular transaction. Okay, but you are not going to update or write this page back to the disk until the transaction commits. Until the transaction commits, then you call it as a no steal approach. Please listen to all these concepts, it's very important. Suppose you have made a updation in the page. How is the updation made? Because you have executed a transaction and the transaction has updated that particular page. Now a time comes wherein you want to update or transfer this page or update this page back to the disk, which is what we have been seeing here and all. How to update, in place updating, shadowing and all that. So in place updating and shadowing, we saw how a page can be updated. Whether you want to put it in the same location, you don't want to keep it in the same location, all that is what we saw. Here what we are seeing, when you can update a particular page. That is the difference. So when you, let us say this page is updated by a transaction. Now I want to update this particular page in the disk. I may use either in place updation or I may use a shadowing concept. But if I cannot update this page in the disk until the transaction commits, that means what? The transaction should complete the execution successfully. That means it will, only then it comes to what is called what? Only then it reaches a commit point. Till then, I cannot, let us say I cannot update this page to the disk. Then I call it as a no steal approach. Okay, otherwise Otherwise, what is the other option? If the protocol allows the writing and updated buffer before the transaction comes. If I'm allowed to update it, if I'm allowed to update the page in the disk even before the transaction has completed, then I call it as a steal approach. We are stealing. Right? So steal is used when you are trying to update the disk even before a transaction commits. Did you follow me? Any clarifications in this? If you want to update the page into the disk only after the transaction commits, that means commits means the transaction has to reach a commit point. It has executed all the instructions successfully. That is called as a no steal approach. If you are trying to update it even before the transaction commits, then you call it as a steal approach. Yesterday's class, we saw two updates. Do you remember? Deferred update and immediate update. We saw that. This deferred update means what? I said the transaction will make all its entries, updations in some local copies in the transactions workspace. In the temporary workspace, it will make all the updation. Only after the transaction commits, it is going to it is going to update the disk or update the database, right? That is what we saw in case of deferred update. In the last class, we saw two techniques, deferred update and immediate update. Deferred update uses no steal approach. Why? Because in no steal approach also, you are going to update the disk only after the transaction commits. Deferred update also, you are going to, I said, make the final entries, final updation in the disk only after the transaction commits. Right?
Yes, ma'am.
Yeah. Right. Next we saw what is called force no force. Force no force means what? If all the pages that are updated by the transaction. Now, not necessarily one page will be updated. There will be so many updations in the updations by the particular transaction. If all the pages that are updated by the transaction are written immediately, they are written to the disk when the transaction commits, then you call it as a force approach. Hence, you call it as no force. If that means you are not writing all the pages immediately, you are writing only those which are modified, you are deferring the update, something like that, then you call it as a force approach. If all the pages which are updated by a transaction are immediately written to the disk when the transaction commits, then you call it as a force approach. Okay, these are the four different terminologies you should know: steal, no steal, force, and no force. Generally, a typical database system, okay, a typical database system will generally use a steal and a no force approach. Generally, it will be like that: steal and no force. Steal means what? It will keep updating the database even before the final commit happens. No force means what? Not all pages will get immediately updated. That is your no force. Generally, this is the method that is followed in most of the typical DBMS or database approaches. What is the advantage of steal approach? Can anyone tell me? Steal means what? I said even before the transaction commits, all the whatever updations are made, you go on updating the disk. What is the advantage of that? And I also told most of the database use the steal approach. Typical database day-to-day usage, they all use steal approach only. Advantage is that it will avoid the need for a large buffer space. When I say no steal approach, what is happening? You are updating the disk only after the transaction commits. So you must keep all the updated pages in your buffer. If you are updating so many pages, you need to keep space, for all that. So no steal approach will require a lot of buffer space. because you are going to update the disk only in the end, not as and when you update. Whereas in case of steel approach, what is happening, before even the transaction is completed, you are updating in the database. So you don't need much of a buffer space. Once it is updated, you will go and update the disk immediately, which is the steel approach. So there is an advantage in this steel approach is there is no need for a very large buffer space, because all the updated pages you have to keep it in the memory in case of no steel approach. Force approach, I said again, force approach means all the pages which are updated, you are going to update it in the disk immediately. No force means you are not updating all the pages immediately. What is the advantage of no force in that case? I said all database typically use steel and no force. Advantage of no force is that an updated page of a transaction which is committed, let us say, it may be still in the buffer, because in no force you are not updating all the pages immediately. Some pages you are updating, some pages you are not updating. So some pages which have which are updated, the transactions are committed, are still in the buffer. That means another transaction, if it wants to update that particular page, you can still do it in the buffer itself. IO is reduced, overhead is reduced. Again, you have to read a page from the disk, again bring it back into the memory. These things can be avoided, because no force means only certain pages are updated. You are not immediately updating all the pages into the disk after the transaction is committed. So that is an advantage again. So that's an advantage. These are some of the important terms that you should understand. Any doubts so far? Any questions? Any questions? Anyone?
No.
Anything that's not clear? So any database typically uses a steel and no force, because there are certain advantages in that. Steel doesn't require a very large buffer space. No force, it will enable another transaction can update it immediately in the same buffer only. Because of updated pages in the buffer, if another transaction needs the same page, you can still update it in the buffer rather than taking it to the disk and again bringing it back to the memory. That kind of an IO transfer and all this can be avoided. Right. Okay, next we move on to another important terminology, which is called as checkpoint. Any idea what is a checkpoint? What do you mean?
Last save point.
Yeah, anyone?
Last save point, ma'am.
Last save point, yes. Anyone else? What is a checkpoint?
It will hold the last save the data.
Correct, yeah. Now, checkpoint, another type of entry in the, it's actually a log entry. One type of entry in the log. One type of entry in the log is it's called as a checkpoint. Okay. So a checkpoint, we generally write it like this within the square brackets. We call it as a checkpoint record. It's a log entry, I said. So you try to make a log entry. You are writing a checkpoint record into the log. Very periodically, you will do it. Let's say every few minutes or every time this many number of transactions are committed, and then you write a checkpoint record. So when do you write it? You write it at a point when the system is going to write everything onto the disk, all the buffers that has been modified. Okay, I said you, so far we were discussing whatever pages are modified, buffers are modified, you have to update it to the disk. So every time you are updating it to the disk, you make a checkpoint record entry into the log. Right? So all the transactions that have committed before a checkpoint, that means they don't have to do a redo operation, may not be required for that in case there is any kind of a system crash, because all their updates will already be recorded in the database during that particular checkpointing. Every time you are trying to transfer some updated data into the disk, you write a checkpoint record, right? Before that record, checkpoint record, whatever transactions are already committed, those all need not be redone if at all there is going to be a system crash or something like that, wherein you want to recover. Okay. So again, the recovery manager has to decide the intervals. I said you are writing it periodically. So at what intervals you have to take a checkpoint. So you can have this interval, it can be measured in time, say every few minutes, let's say every 15 minutes, every 30 minutes, or you can also take it based on the number of committed transactions. So if I say I'll do a checkpoint if these many number of transactions are committed, every time 10 transactions are committed, I'll take a checkpoint. Something like that, it can be done. So what are the steps that a checkpoint, if a checkpoint has to be taken, what are the things that has to be done by the recovery manager? First and foremost, all the execution of all the transactions will be suspended. Temporarily, of course. You have to suspend the execution of all the transactions temporarily. Then, all the memory buffers, memory pages or buffers have to be, which has been modified, has to be written onto the disk. Whatever memory buffer has from the memory to the disk, you are making these updations. That has to be done. After this, you write a checkpoint record in the log. And then the last step, very important step, you resume the transactions which are suspended. These are the 4 steps that you do when you are trying to do a checkpoint. When the recovery manager tries to do a checkpoint, these are the steps that has to be done. So all the transactions first has to be whatever is under execution, they have to be suspended. After you suspend all the transactions, you have to write all the memory buffers, whatever has been modified. You have some pages in the memory which is modified, right? Those pages you have to write it into a disk. You go for the force write approach. Force and no force. We saw 2 approaches, right? You will actually go for the force write. Force write means what? All the pages are written immediately, updated into the disk. Then after that, you write a checkpoint record to the log. And you will also write the log also is written to the disk. And after this, you resume the transactions. You resume the transactions which were suspended. So when you write a checkpoint record, till this point, whatever has been updated or whatever transactions has been committed, all this, as I said, need not be redone if at all there is going to be a crash later when you try to recover, because already those updations are written onto the disk, they'll be intact. Right? Now, sometimes, what happens, we have something called as fuzzy checkpointing. Fuzzy checkpointing means what? I said in this case, with the checkpoint, normal checkpoint case, what did I say? First step is what? We temporarily suspend all the transactions. What is the disadvantage of this? Unless you finish all the updations and then write a checkpoint record and then resume, that much of delay is there, is it not? It will delay the transaction processing, right? So what we can do, we can still go on with this. To reduce this delay, we can use another technique, which you call it as fuzzy checkpointing. You can resume the transaction after the checkpoint record is written. You don't have to wait for this particular second step to get over. You can resume the transaction. Thereby, you will try to fasten the execution of the transactions, and it will not be very slow. I mean, the delay will be reduced to a greater extent. That is called as fuzzy checkpointing. Right? So once you write a checkpoint record, you can resume off the transactions, whichever has been suspended. You have to suspend them. But once you write a checkpoint, log, you can start resuming the transaction, so that you need not wait for this force write to be completed, so that the delay in the transaction is reduced to a larger extent. Okay, that is about checkpointing and fuzzy checkpointing. Next, we see what is transaction rollback. It's again a very important concept. What is a transaction rollback? Any idea? Can anyone tell me what is a transaction rollback?
Undoing a transaction.
Undoing all the transactions whenever a transaction fails.
Yes, ma'am.
You may have to roll back that particular transaction. Yeah. There is something also called cascading rollback. We'll talk about it. Okay, I will continue this topic now. I'll just finish the attendance and then continue. I'm not completing the class. Okay, so I'll continue the class after attendance. Answer your attendance, Anaga.
Yes, ma'am.
Today you see. Okay. Abhilash,
Yes, ma'am.
Akhil,
Yes, ma'am.
Akrut,
Yes, ma'am.
Anusha,
Yes, ma'am.
Arpilla,
Yes, ma'am.
Danika,
Present, ma'am.
Banu,
Yes, ma'am.
Bhargav,
Ma'am.
Grandchildren,
Yes, ma'am.
Chandana, Chandana, Charan,
Yes, ma'am.
Darshan, Diksha,
Yes, ma'am.
Dakshayani,
Yes, ma'am.
Kishan,
Present, ma'am.
Harshit,
Yes, ma'am.
Hema, Uma,
Present, ma'am. Present, ma'am.
Jayant, yeah, Jayant, Divya,
Yes, ma'am.
Kaushik,
Present, ma'am.
Lakshmi, Lavanya,
Present, ma'am.
Manish,
Present, ma'am.
Manoj,
Yes, ma'am.
Mohit,
Yes, ma'am.
Naval, Navya,
Present, ma'am.
Nikhil,
Yes, ma'am.
Pandra,
Present, ma'am.
Pavan,
Yes, ma'am.
Pooja,
Present, ma'am.
Purnima,
Present, ma'am.
Raman,
Present, ma'am.
Rashmi, Rupak,
Yes, ma'am.
Sai Kumar,
Present, ma'am.
Samir,
Present, ma'am.
Santosh,
Present, ma'am.
Chadam,
Present, ma'am.
Sharan,
Present, ma'am.
Shashank. Shashank isn't there. Sheetal,
Present, ma'am.
Shivani, Soumya,
Present, ma'am. Present, ma'am.
Vishnu,
Present, ma'am.
Sugandhini,
Present, ma'am.
Sushma,
Present, ma'am.
Sushmita BS. She's not there. Sushmita, you?
Present, ma'am.
Tirtha,
Present, ma'am.
Tripti,
Present, ma'am.
Varsha and Veena.
Present, ma'am. Present, ma'am.
Yeah.
Ma'am, Chandana, present, ma'am.
Chandana, I called you, right? Chandana, okay.
Ma'am, Shivani present,
Right.
ma'am. Mic issue.
Yeah?
Shivani present, ma'am. Mic issue.
Yeah, okay. Right. So I was talking about transaction rollback, right? So whenever a transaction fails for whatever reason, so the transaction could have failed for so many reasons. What are the reasons for failure? We have already seen that in a couple of classes back when we started with the transaction. We have seen why a transaction could fail. We have some what to say. Catastrophic failures, we have non-catastrophic failures. We had listed, if you remember, around 6 to 7 failures, types of failures. I don't know how many of you all still remember that. 1 to 4 and are comes under the catastrophic, and 5 and 6 and non-catastrophic, or the other way around. I'm not able to recollect that. But we did make a classification of what are the catastrophic failures and what are the non-catastrophic failures. So why I took that concept here is a transaction can fail because of any of the failure. Because of the any of these reasons, a transaction can fail, more importantly, after updating the database. That is where the rollback concept comes. After you update, so far we were seeing when it can be updated, how it can be updated, and all that. After you update, if the transaction fails for any reason, then there is a need for us to roll back the transaction. Okay, if any values have been changed by the transaction, so that means I said you are written the updated the database means the database has already been written with the new values. That means there has been some changes in the values in the database, but that particular transaction has failed to complete. Then you have to restore restore it to the previous value. What is the previous value called? Anyone? You have to restore it to the previous value. What is the previous value called?
Checkpoint.
No. What did we talk about? Two different value, old value and the new value. What are they called?
BFIM.
Yeah, you have called. Correct. BFIM is your before image. That means you are restoring it to the. Who is that? There we are restoring it to the previous values. Previous values means you are restoring it to their BFIM. So what kind of log entry you should use here? We have to go in for undo type log entry. In the beginning of the class, I said there are two types of log entries that we discussed. One is, I will show you if I have that copy here. Where is it? Yeah, we have seen here redo type and undo type. These two types of, here it is. Two types of log entries are there for a write operation. So whenever you want to restore it to the BFIM value, then you have to go for this undo type log entry. Because using this undo type log entry, you can restore the old values of your data items, which can be, so you are trying to roll back into the new values. Next, we will be seeing what do we mean by cascading rollback. So that I will take it up in the next class. We'll take up a couple of examples also and try to understand more on cascading rollback and more on transaction rollback. All right. So let's continue in the next class. Thank you.
Thank you, ma'am.
Thank you.